Over the past decades, wireless transmission systems have evolved to provide voice communications in harsh and dynamic environments. Using digital coding and modulation techniques, reception in high scatter and even some non-line-of-sight situations became possible. But as the use of cameras, laptops, tablets, unmanned systems, computers, and other bandwidth-hungry devices continues to increase, so too does the need for high-performance communication systems to tie them all together. But today's digital systems have approached fundamental limits in their capabilities, and still lack the data capacity and ranges demanded by today's missions. Mimo, multiple input, multiple output, is the revolutionary technology that is enabling commercial technologies such as 4G LTE, WiMAX, and Wi-Fi to achieve unprecedented data speeds over longer distances than ever before. Mimo works by utilizing spatial diversity to send data over multiple transmission paths. The probability of getting the data across the link is increased, and we are able to increase the capacity of the link without increasing the RF bandwidth. But commercial, standards-based MIMO technologies typically come with inherent limitations in range, mobility, flexibility, and operational environment, which makes them poorly suited for tactical operations. MN MIMO is the answer. MN MIMO, or Mobile Networked MIMO, is a revolutionary waveform which blends the benefits of digital COFDM modulation, MIMO antenna techniques, and a flexible and robust mesh networking layer. Silvus Streamcaster radios utilize MN MIMO to create a fluid, self-healing, self-forming mesh network. Each link in the mesh gracefully adapts to changing channel conditions to provide the optimal throughput for a given environment. All radios in the network share a single frequency, and traffic is automatically routed through the mesh via the most optimal and efficient path. Network topology continuously adapts as radios leave and rejoin the network. The network is flexible and self-managed, requiring no intervention from the user. Additional nodes can be added to the mesh to allow connectivity between a variety of assets, including unmanned vehicles, high-speed aircraft, and more. Independent third-party field trials of MN MIMO technology have validated its advantages over single antenna systems, including increased coverage area in urban terrain, improvement in-building penetration and immunity to interference and jamming. Additional MN MIMO benefits include more simultaneous channels and users, more reliable connectivity, reduced power consumption, increased range, and lower probability of detection. As missions get more advanced, the need for reliable, high-bandwidth communications will continue to grow. MN MIMO provides a path forward, enabling next-generation operations today.